All right. Thanks everyone for joining us. I'm Saurabh. I'm a research analyst here at the block. And today I'm thrilled to be moderating this panel where we are going to discuss all things layer 2. Many of you are already familiar with what layer 2s are. But for those who aren't, layer 2 networks are one of the ways of scaling Ethereum or any blockchain for that matter. Essentially, the idea is to perform computations of Ethereum and send the results back to it in various ways. But one may ask, why do any of this? Since the DeFi summer of 2020, Ethereum gas fees have remained elevated almost until the recent times when the market started cooling off. Although some of the alternate layer ones popped up during this time and they claim to be cheaper and faster than Ethereum, they came with their own set of challenges. For example, some of them stopped producing blocks for hours together on multiple occasions. Ethereum being decentralized enough at the base layer does not face downtime issues. So, Ethereum is decentralized, but it's expensive. The layer 2 solutions built on Ethereum are here to offer users cheaper access to Ethereum. However, they come in a lot of flavors. Not every L2 is the same. Their designs are nuanced and they make trade offs at various levels. I can't wait to dig deeper into this with our stellar panel of four experts. Today, we have with us Alan Chu. He's the CEO at Enya Labs, which runs Boba Network. We have Ed Felton, who's the chief scientist at Offchain Labs running Arbitrum. We have Eli Ben-Sasor, who's the co-founder and president at StarkWare, and they are developing solutions like StarkNet and StarkX. And lastly, we have Sandeep Nailwal, who's the co-founder at Polygon, developing solutions like Hermes, Maiden, Nightfall, and Zero. I must mention that during the course of writing this report, we have learned so much from all the teams we spoke with, and our report revolves around our conversations with them. I'm grateful to have been able to speak to our panelists and thank them for coming on. Before we get started, I want to give a big thank you to our sponsor Polygon for this event. Without them, this panel would not have been possible. They also commissioned an in-depth research report which we published a couple of weeks ago. As one of the authors of the report, I'm going to shamelessly ask you to go and read it. Andrew and I have tried our level best to make it as consumable as possible for you. And with that, let's go ahead and get started. We can start with brief introductions. Maybe you want to share some of your backgrounds. We can start with Alan, Ed, Eli, and then Sandeep. Alan, over to you.
Thank you so much, Saurabh. It's a pleasure to be here, and good morning, everyone, or wherever you're in the world. I am Alan Chu, founder and CEO of Enya, and we started Boba really with the goal of making the benefits of crypto accessible to everyone on the planet. And of course, that's a long-term goal and very ambitious goal. And the reason we built a layer 2 on Ethereum is because we wanted to make sure that we offered the same level of security as Ethereum to our users, while at the same time to dramatically lower gas fees. And then on top of that, we also recognize the limitations that exist today for developers who are developing smart contracts and wanted to give them an easy way to offload complex compute workloads off chain. And that's what led to us creating this hybrid compute protocol that's unique to Boba. I myself come from a distributed systems engineering background and then spent a few years in venture capital before starting Enya.
Yeah, Ed.
Great. Hi, everybody. I'm Ed Felton. I'm a co-founder and chief scientist at Offchain Labs. We make Arbitrum. My background is as an academic. I taught at Princeton University for 28 years in computer science, and then later also in the public policy school. I served in the US government as deputy CTO of the United States and a senior advisor to the president before going back to academia and then founding Offchain Labs. Our team has been working on layer 2 scalability solutions since 2014. That's when the original version of Arbitrum was born. And we've really focused on maturing the technology through its generations and delivering value to our consumers, to our users and developers. We're an optimistic rollup. We'll talk more about how that works, but currently deployed on mainnet and with our second generation system on testnet.
Yeah, Eli, you can go next.
Hi. So first of all, I apologize. I want to show you what's written on my shirt, right? Apologize for the glitch. Eli Ben Sasson, co-founder and president of StarkWare. The way I arrived at blockchains was I was doing research on theoretical computer science. I was a professor at Technion, and at some point, for me, it was in 2013. Swallowed the red pill at the Bitcoin San Jose conference. I was a co-founder of Zcash, and in 2018, along with three other co-founders, Uri Kolodny, Michael Ryabtsev, and Alessandro Chiesa, we founded StarkWare. The idea at the time, and still is, we have this technology that we think is really great called ZK Stark that we invented and then honed inside the company and evolved a lot. And we think it's a really great technology that can do a lot of things like scaling and also later on privacy. And that's what we aim to deliver to the world.
Yeah, go ahead, Sandeep.
Yeah, hello everyone. I'm Sandeep. I'm one of the co-founders at Polygon. I also come from a computer science background. I have programmed on blockchains before, but at Polygon, I take care of all things business, which includes business development, marketing, and a lot of different things. But I stay deeply, still deeply connected with the tech side of things, especially on the product strategy and everything. And about Polygon, Polygon is basically we like to think of Polygon as like kind of AWS of Web3. Basically, we believe that Ethereum has already emerged as kind of the settlement layer of this internet of value that we are creating. And we believe that that will remain as a settlement layer. Any layer one eventually, if it's decentralized enough, it cannot process end user transactions. So we believe that end user transactions will move on to these layer two solutions or these secondary blockchains, in that sense. And at Polygon, we have a much larger kind of mental model of how Ethereum will scale. So we believe that there will be independent blockchains, there will be partially dependent blockchains, and there will be layer twos also, which is kind of getting validated into the market currently. At least currently, that's how we see the market and the end developers need are. And we want to be present across the spectrum. So we have something called Polygon Edge, with which you can create your own dedicated blockchains, which are kind of like Polygon, which are called Polygon Supernets. And then we have public blockchains like Polygon POS, and then we have the layer twos, especially focused on the zero knowledge technology, where we are building three different flavors of that, of those layer twos. Yeah.
All right. Thanks a lot for the introduction. I think many of you spoke about why Ethereum, but I would like to club like two questions here. So, how does Ethereum benefit the solution that you are building? One, why should the average user care about decentralization? I mean, if you can like just throw some light on that. Let's start with Alan.
Well, we wanted to build on Ethereum because one, it's the most decentralized smart contract platform out there and offers a very high level of security. And when we're talking about applications like DeFi, where real assets are at stake, we feel that that's important to our users. And of course, we're not stopping there. But scaling Ethereum is a long-term goal, and the layer 2 architecture offers is part of the future of Ethereum, because the notion of taking execution and computation off the main chain and separating that and scaling that independently of the settlement and data availability layer opens up a much broader design space for the infrastructure and for the future scalability of this platform. And we believe that actually other layer ones will eventually follow a similar model in order to continue scaling.
Yeah.
Sure. I think in answer to why do people want decentralization, decentralization is what blockchains are for. If you don't want decentralization, why are you using a blockchain at all? That's the benefit that they bring. And so if we were to give that up in order to achieve scaling, well, then we really just would be, say, AWS or something like that, not the AWS of blockchain, which I think we all aspire to be, but we would just be AWS. So decentralization is where it's at, right? So there's this so-called blockchain trilemma of decentralization, security, and scalability, right? And basically what rollups do is to break that so-called trilemma. Ethereum gives you scalability and security, and it's really the best thing out there for that purpose. And what we bring to the table fundamentally is the third piece of that triangle, which is scalability. Without giving up the security and decentralization of Ethereum, we can give you scalability as well. And Ethereum is recognizing that. This is the so-called rollup centric roadmap that Vitalik Buterin has written about. The idea that Ethereum is evolving toward becoming a data availability layer and settlement layer for rollups, but rollups will be in the future where the execution and state of Ethereum-based technology will live. So that is the future. It's where Ethereum is going, and it does give you the best of both worlds. You have that base of security and decentralization. You have a layer 2 on top of it, which needs to be designed to not give up decentralization or security. And then you can build up to higher scale. So that's what we're all about. It's what we've been focused on since the beginning. That's where the idea of Arbitrum came from way back when, this question of how can you take what's great about a decentralized smart contract system and scale it up to a much larger scale.
Highly.
I'll be brief because I don't have much to add to what Alan and Ed have said, because yeah, the blockchain is all about decentralization, and you know, you need all the scale that you can get by any technology which delivers it. So I mean, you have here 4 variants of different technologies that offer scale, and I think you need all of them.
Sandeep, you have anything to add?
Yeah, I mean, I think the original question was that how does Ethereum benefit from it, right? So, like, you know, all the layer 2s that we all are building, they actually settle back or, you know, provide cryptographic proofs back on Ethereum. So essentially, is Ethereum getting more usage in that sense? And in our belief, we believe that, you know, Ethereum is already on the way to, you know, become a user to chain kind of paradigm to a chain to chain paradigm. Instead of like end users interacting with the Ethereum chain or layer 1, you know, in some time we would see most of the users interacting with these layer 2 transaction layers, and these layers are then settling back into Ethereum. And we definitely, like, as you know, Eli said that, you know, I mean, it's I mean, for these layer 2 variants, you know, we believe that there will be multiple you know, multiple products in the market will be, you know, which will have their own trade-offs, and, you know, developers will choose you know, what fits them the most. And why build on Ethereum, the layer 2? I mean, you know, Ed really you know, mentioned is that, you know, if you don't need blockchain, like, you know, I mean, I really hate that narrative of like decentralization doesn't matter. I mean, it matters, you know, it doesn't matter until it does, which what we saw with the, let's say, the recent you know, stable coin crisis and whatnot also. But overall, by other things also, I mean, if you don't have decentralization, why even use blockchains? You know, we have very, you know, at least like a million x better performing servers. You know, you can use those servers. Why use blockchains at all? And secondly, like, you know, why build layer 2 on Ethereum is that you want to build a layer 2 when there is enough block space demand on layer 1. So, you know, I mean, that's there only on Ethereum. Like, there is no other blockchain which has sufficient block space demand on the layer 1. So that's why they right now don't need layer 2. And Ethereum is the only that successful platform. So yeah, that's
Yeah,
why.
that makes sense. Let's get into some of the specifics now, right? I mean, I think we have warmed up enough. So what makes, I think everyone here is representing a roll-up solution, right? It's either an optimistic or a ZK roll-up. So what makes you confident that roll-ups are the reliable long-term scaling solution for Ethereum? Yeah, I mean, let's start with Alan. Yeah.
Yeah. So going back to this notion of what's the best way to scale a distributed system or decentralized system, and if we continue to tightly couple execution and settlement and data availability all around one blockchain, then we're really handcuffing how we're able to scale the infrastructure. There is a cost to be paid for decentralization, right? There's no free lunch in the world. Decentralization has a lot of benefits, but if we take the original design of Ethereum, that requires the same computations to be repeated across all the nodes across the network, then the compute capacity is going to be very, very limited. Then there's no way to scale. And so the idea of taking computation off the main chain and essentially centralizing that, but also writing enough data back to main chain to, one, prove that the transactions are processed correctly, and two, be able to reconstruct the state of a layer 2. It's a brilliant move, and it unshackles the infrastructure builders to be able to scale compute much more cost effectively. And that, of course, then leads to lower cost of using the infrastructure, and that induces a lot more demand to come into the whole Web3 crypto ecosystem. And which is why we believe that Rollup is here to stay, because it's just essential to the scaling of smart contract blockchains.
Yeah. Ed?
Sure. Rollups are really the only approach that provides that gives you scalability without sacrificing that decentralization and security of Ethereum. Someone wrote in the questions about layer one Ethereum is relatively open. Anyone can run a node. Not only can you run a node, but you also can get all the data you need to be a first-class citizen in the system. And that's what makes a rollup. It's the availability of data to every node and every participant in the system, so that they know everything that has happened in the system and don't have to rely on some centralized party or in order to get that data. So basically, rollups are the only way that's out there right now that gives you scalability without sacrificing some of the other pieces of that blockchain triangle of security and decentralization. I mean, that's why we're all in on rollups, and we think they're really the only game in town. All of us differ on what kind of rollup is the best, but and that's healthy competition. But I don't think we differ on whether rollups are the right approach.
Yeah, Ellie, you want to add to that?
Yeah, they're the next step in offering more scale, but we're already seeing that there's more than just rollups, and I'll give some examples that will be evolutions and improvements on them. One thing, so when people say a rollup, they technically mean that all the data must sit on chain, but there's also validium or volition, in which the data now is offered to be partially off chain, and which means that you're offering the users a trade-off in, do you want layer 1 security and also somewhat layer 1 costs, or do you want, at least temporarily, lower costs but also other security assumptions? So that's one direction in which rollups are already transforming into something different that offers more. Another thing, which at StarkWare we're very proud to innovate as well, is the concept of layer 3 and more, in which so rollup means all of the data needed to recover and everything that's happening is verifiable on layer 1. But with validity rollups, if they're Turing complete, now you could sort of recurse on this, and you could have room for a layer 2 that on it you have various private instances of high scale systems, like let's say a StarkX system. You can also have small ecosystems that operate their own StarkNet on top of StarkNet. And that's a second direction that is already in motion. And just to add to that, right now, it's all, you think of like this, you have a layer 2 that basically sits only on Ethereum, but we all know that there are other blockchains out there. Now, the whole question of security and crypto economic dealing with bridging what is currently a layer 2 to multiple chains is a huge research problem. But I'm hopeful that this research problem might be solved, and then you'll see an even more intricate world where it's not just a layer 2, a rollup of, let's say, Ethereum, but maybe this ecosystem that is, can segue or improve both on Bitcoin and on Ethereum and on some other layer ones. So I don't think we'll stop with rollup. There's at least Validiums, layer 3s and beyond, and multiple connections of one rollup. Anyway, so it will go further and deeper.
If I could just jump in quickly here, there are some differences of terminology between different parties in this space. What Ellie calls Validium, our version of that is called AnyTrust. I think a lot of people are building similar or designing similar sorts of things, and I agree pretty much on that roadmap as being where this is likely to go. But I consider this all part of a sort of big tent roll-up style design approach.
Yeah, I mean, from my side, I would, for the audience which might not have that much technical details on how roll-ups work or what exactly is layer 2. Essentially, it's very simple that we want to do some computation, but we don't want to do it on the Ethereum main chain itself. We want to do it somewhere else, but yet be able to prove everything back on Ethereum. And right now, the approach that that is feasible, that looks feasible, is that of rollups, and rollups, which is basically with optimistic rollups or with zk rollups, as Eli was saying, that you can also do this verification of external computation using maybe validiums, because there is a zero knowledge technology used. But yeah, I mean, overall, that's the basic idea about layer 2s, and I think we're going to see multiple versions of it, and we are already we just discussed that there are going to be probably layer 3s, interoperability, and overall this layer 2 technology is going to evolve further and further, and maybe in coming 1 or 2 years it might look very different than what it is today. One of the things I would add to what Eli was saying, that what we are also working, that's why we have 3-4 versions of these zk rollups, is that for example, Polygon Hermes, it is a fully zk EVM kind of rollup, which will have full compatibility with Ethereum Solidity code, assumingly, and we are very, very advanced in terms of reaching that full availability for that network, at least on the testnet, very in a very short duration of time. Then we have other solutions, like for example, Polygon Zero and Polygon Maiden. They are building very different, their construction is very different, and what they could do is they could actually offer much much kind of extensive computations, like in a simple world, I'm trying to say that much more extensive computation than what is provided by EVM, and then still be able to prove all of this computation back onto Ethereum. So maybe in future, I mean, of course, it's nowhere near, but maybe it's you could run much larger computations off chain, like in some applications, who knows, like Facebooks of the world. They are running extensive, very big computation in a single node setting off chain, and yet be able to prove their computation, what they have committed as to the community back into Ethereum via some sort of thing. So the roll up or the roadmap we have with the roll ups, and the kind of incremental technologies that will come out of that is also pretty large. That's why we are we have 2-3 spread out approaches on that. For example, Polygon Nightfall also, that we launched yesterday only, that's a roll up, that's a combination of optimistic plus zk roll up, and it's kind of, in a simple way, it's kind of zcash as a layer 2. So but this is for enterprises to have some of these private computations, private token transfers and things like that, which we already see, like Ernst & Young already announced a particular project on that, and there are more things that are being built on something like that. So there will be multiple versions and multiple uses of such rollups in the future.
Oh, I think there's a lot to unpack here. I hope we have some time at the back end, and I think I can come back to you, Eddie, on what you mentioned and how these worlds might get morphed together. So let's take a step back, and so why did you choose optimistic rollup or a ZK rollup, and what was your motivation behind it? And I know that there is some sort of hybrid compute that Boba is doing. So maybe you can walk us through what your thought process is.
Yeah, we chose the optimistic roll-up route because one, the technology was already ready when we started building Boba, and we didn't want to wait an indefinite amount of time before going mainnet. And we also like the idea of using Geth itself to as a layer 2 rather than emulating an EVM. As we all know, emulation is non-trivial, obviously, and as EVM itself changes, you got to change your emulator to keep up. Whereas using Geth itself directly is going to provide the highest level of compatibility with EVM smart contracts, But further to it than that, we wanted to build on the optimistic rollup architecture to enable hybrid compute. And this is important because developers that are writing smart contracts will know this very well. Anytime they attempt to do any sort of non-trivial computations, it becomes impractical very quickly, right? Too expensive, too slow to run them on chain. And you can't do floating point operations even. So there's a whole class of computer science approaches to solving problems that are just not practical on chain today, and it would be a pity to not be able to incorporate those techniques into the future of Web3 application development. So we wanted to create a very easy way for developers to be able to execute really complex compute workloads within the context of a Web3 application. And that's why we created hybrid compute. And essentially how it works is when you're writing a smart contract, you specify which RPC endpoint you want to invoke. And our modified Geth is going to make that call on your behalf. And the response will come back atomically within the same transaction. And the responses become part of the call data that we then write to layer 1 so that independent verifiers could replay those transactions and get the same results. And this really opens up a lot of more possibilities for the developers. You can call an existing API of a Web2 entity or create your own and run a machine learning model off-chain for NFT valuation or for a much more complex trading algorithm for DeFi than possible on-chain. You can also use it to synchronize your on-chain NFTs with the gaming engine that is, of course, running off-chain. So the possibilities are really exciting for developers who wish to take advantage of hybrid compute. And everything that we've done is open source, so it's all out there. And we'd love to, can't wait to see what developers build over the next couple of years on this platform.
Ed.
Sure. Okay. So if you're comparing optimistic versus ZK, you need to be careful not to fall into the usual trap. And the usual trap is to compare today's optimistic systems against some postulated future ZK systems. The reason that we chose optimistic for our current implementation is because that was the technology that was feasible to implement full fraud proofs for and integrate them into a working system. And to do that, not only today, but to do that back in 2019. And with every version since then. So if you want to have working fraud proofs for general EVM computation today that run at scale, optimistic is what you have to use. And I know that's true because there is no other example of it that is fully fielded today. Now, fraud proofs are one component of the design of a rollup. If the day comes where we believe that ZK rollups are a better choice, then we would switch. Or if some kind of hybrid is feasible and we think we can actually deliver it with EVM compatibility, really implemented and it's at the scale that our user base and developers want, we would do that. But today, the thing that you can actually deliver to users with all of the features they want and fully integrated is optimistic, which is why we use it.
Yeah, Ellie,
Yeah, so I'll answer. The question is, why did we choose to go with the technology we went? The answer is quite prosaic. I mean, we started with the technology, which we understand very well, and we invented it, we developed it, we understand the alternatives. We also did a bunch of research on, snarks and other things. We think it's a really good technology, and it is the right technology for scaling. And we said this, more than 4 years ago when we hit the road, and this hasn't changed. I mean, that's the short answer to why we went with this technology. Um, and amazingly, I mean, when we started, it was okay. I mean, I personally am like euphorically optimistic and maybe insanely optimistic. And I had this unfounded, complete belief in the ability of the team that we had to deliver on, full Turing complete computation at scale for multiple things over blockchains. Um, and I mean, it turned out to be the case. We are offering today. We've minted the most NFTs. Systems like DYDX are rare, diversify, immutable, or I think very happy with the technology, and we're now offering it to all developers, and they seem to be flocking to it and really enjoying it. So it's true that it's not EVM. But the ultimate goal is not, I mean, EVM is not a holy architecture given to us, centuries ago and is canonized. It is a means to an end. And the end is having amazing systems built that are decentralized and offer integrity by various means. And what the amazing ecosystem of Starknet is now showing us and the world is that there are all these beautiful applications and smart contracts that you can do that you actually can't do, or you can't easily do, or you can't do within the gas limits on the EVM, and that's really, really beautiful to see. Anyways,
Yes, Sandeep, if you want to add something to that.
Yeah, I mean, so from our side, like, we obviously we have one optimistic plus zk rollup combination, which is not zk rollup basically, but optimistic rollups plus zk technology with this Polygon Nightfall. But generally, in terms of our scaling efforts, we are more focused on zk. We have also been involved very closely previously in Plasma, and I think, like, there is a certain level of evolution that happened with the optimistic rollups coming in from Plasma in some form, very minor form, but there's things. So what we believe is that there are few things that with optimistic rollups, like the 7-day challenge period, especially because when we have a public chain live, right, where users are interacting, and we see the end user problems and things like that. So that's where because of the fraud proofs, you have this 7-day challenge period. And then also, in order for the public challengers to interact with the, or if something goes wrong on optimistic rollup, and if public challengers somebody wants to challenge a particular transaction, they have to have the data also on chain. So due to that, the data cost also is slightly higher, but definitely it's very secure, as Ed said. Like, I mean, it's currently the technology that is available today. But with zero knowledge technologies, those things are not there, because zero knowledge technology, again, for very layman terms, uses something called validity proofs, which means that you create a zk proof and put it back on a particular Ethereum smart contract, which is based on the construction of the rollup. And if it matches, that means everything is correct. So you don't need to have all the data, and you can exit immediately. Let's say in 5 to 10 minutes, you can exit your funds or assets from the layer 2, and the operators cannot actually cheat with it. So you can have the data off chain also and bring it only when something is wrong and things like that. So that's why, like, which is called Validium, which what Eli was also referring to. And when you don't have to store all the data on Ethereum, you can have much lesser cost transactions and things like that. But currently the ZK proof verification and all those costs are very high. That's why, like, I agree with Ed that optimistic rollups are the technology that are available today. But we were already building Plasma previously, so we thought that I mean, once we want to put the efforts over here, we want to put it on ZK probably, which currently looks like more futuristic. But I also believe that if when this ZK technology is proven, more and more optimistic rollups will also adopt the best parts of that and provide more stronger solutions. So eventually all of these solutions are going to be commoditized, right? So I mean, from our side, we are more focused on end user and developer experience and getting more applications and adoption onto the chain, because most of these technologies, just like operating systems and the web technologies, they will get eventually commoditized more and more. So
Right. I think you've provided, I mean, there's a nice segue into a couple of topics here. I want to pick on EVM compatibility before we dive into the data availability stuff. So EVM compatibility, like how important is it? How are you planning to either achieve it, or what happens if you let go of it? And what are you gaining if you let go of that? If you can just talk us through EVM compatibility. Alan, let's start with you.
Yeah. So from a computer science point of view, it's not critical, right? There are many different ways to enable smart contracts on a blockchain, but from a developer adoption point of view, it's absolutely critical. That's where most of the developers have chosen to build on. And as a result, if we want to attract developers to our layer 2, we have to offer the best EVM compatibility possible. Because otherwise, it's going to be a huge lift to ask developers to start writing their smart contracts from scratch or make heavy modifications.
Yeah, let me jump in there as well. It's, our experience has been that developers absolutely want EVM compatibility. They want not only EVM compatibility, but also Ethereum node compatibility, meaning that the same RPC, the same API that an Ethereum node exports to the network. People want that. And the reason they want it is not just because developers are familiar with Solidity as a programming language. It's because there's a whole ecosystem of tools that are built there. Whether it's things like whether it's various analysis tools, whether it's things like the tracing API that is offered by that Ethereum nodes offer. Having compatibility with that is what allows all the other tools in the ecosystem to work with your stuff. You want to be compatible with wallets? Well, you better support the same gas estimation that Ethereum has. You want to, so there's a whole ecosystem of tooling. It's not just EVM. It's really, can that stuff work with you, or does the whole ecosystem of tools need to be rebuilt from scratch for your system? So, we've really focused on EVM compatibility and Ethereum node compatibility. And just because the market and our user and developer community has demanded it.
Eli, I'm guessing you have a different experience, so why don't you add to it?
Yeah. So our experience is it's very funny. Like when over the years we've been told a bunch of things. Like, one of them was, it must be EVM compatible, or else it won't work. And of course, I'd love for what we do to be EVM compatible. The only minor problem is the problem we really want to solve, which is scale. Doesn't work as well if you try to make a validity-based system EVM compatible, which is why we needed, or by the way, Python compatible or C++ compatible. I would love to Stark prove, C++ programs or x86 or you name it. I would not want to develop a new language and tooling for it, okay? But the really burning matter is, can you get the scale you want and write the stuff you need? And what happened was, I mean, this is what happened for us at StarkWare. First, internally, we needed to reach much higher scale using this new method of Stark proving. And the best approach was to write a very minimalistic Turing complete machine and a language for it. And once we had that, we could deliver all this amazing scale that by now is well known, processing more NFTs than on Ethereum itself, having a week with more transactions than Ethereum at a fraction of a percent of the gas cost, processing more than $500 billion worth of transactions for DYDX alone. All of this is based on programs written in Cairo. And then the next step was, okay, if our team finds this to be good enough to build a whole bunch of stuff, let's let the world also try. And there were people saying, oh, this will never work because it needs to be EVM compatible. But the reality proves otherwise. We have, I think I just posted in one of the questions a link to the list of projects. This is just the projects we are aware of. Probably there's twice or thrice more that we're not aware of. People are building projects and are happy and content because they understand that this is their fastest way to real scale. Now, would I like better tooling? Would I like more extensive, a better experience? Yes, sure, and we'll get there. But what I want most is to offer the world the same ability to scale that as we have displayed for our standalone systems. And that's why we went in that direction.
Well, I think it's an open question whether you have to choose, right? Do you have to use a custom language format tool set in order to get scale, or can you do it without, or can you do it within the standard framework? We believe you can do it within the standard framework, and we think we're delivering that and we're continuing to improve it. But and certainly this is an ecosystem market, and so we believe strongly in compatibility as being key.
I don't want to opine on. I agree that within the optimistic world, I think all solutions are, to the best of my knowledge, to some extent EVM compatible. I can say, and here's like a prediction or a prophecy within the validity world, the so-called ZK rollup. They don't offer ZK. That's why I don't like to call them ZK rollup. But within the validity rollup ecosystem, StarkWare is the outliers. Everyone's claiming to go for ZK EVM. It's a big thing. My prediction and prophecy is that this won't work, and everything will basically, in the end, in the validity world, rely on Cairo and Starknet. I think that's what's going to happen. And you could, I don't care if someone tweets it out and we check it in 2 years' time. I think this is what's going to happen. Not because we don't like Solidity and EVM, we love it, but I just think it's a new technology that requires. You think about it. The whole point. Why did Solidity or the EVM emerge? There were amazing programming languages out there before, right? We're talking about 2015. The answer is that there's a new set of constraints when you're building something like a layer one, and EVM is an amazing solution for that. Well, when you're trying to build cryptographic proofs over finite fields with a whole bunch of other constraints, EVM is not it's not the best solution. You need a different thing. And this best solution is, I think, given by Cairo. So that's my problem.
No, that's a great point. It comes down to ultimately, as builders, what we're optimizing for, and the different trade-offs. And I think it's beautiful that we have a diversity of layer 2 solutions, each optimizing for a different design angle, and that gives developers more choices, and ultimately the users win.
Yeah. On our side also at Polygon, we are very focused on EVM compatibility. We have seen our ecosystem grow, and that EVM compatibility has a very big role to play into it. But I also fully agree with Eli that there is a space for and for like different kind of programming languages and all that, which many developers might want to use. And mind you, we have still not seen the mass adoption of blockchains. Like I think overall, I was reading some statistics. I think 1% of the global developer workforce has interfaced with Web3 yet. And in the traditional world, there are like the high quality programmers. They have their own choices of programming languages. So again, like coming back to the Polygon, like EVM remains a very important part of our core product suite, and we are that's why like ZK EVM that we are building. And I believe that we'll be the and many industry participants also said that we'll be probably the first one to market with the EVM, ZK EVM, in rather like maybe in a matter of weeks. I think we'll have a test net. But apart from that, with the Polygon Zero and some of the other solutions that we are building, for example, Maiden is not EVM compatible. It will allow you to have different programming languages. Zero also, we eventually feel that EVM, because it has a limited set of opcodes, right? But if you want to add more opcodes, more different kinds of computations into it, so with Polygon Zero, we are already taking that into account, and eventually, we believe that it should be able to provide developers with more programming languages. So I mean, definitely choice should be there, but currently, like EVM is leaps and bounds ahead of anything else in the market. So that also has to be fully respected.
All right. Thanks a lot for those responses. So I was going through the questions, and I think Arnold asked a question, which was related to data availability, right? So Celestia, I think, claimed that data availability is probably one of the biggest or the biggest bottlenecks, one of the biggest bottleneck to scale rollups. Is that the case? And if it is yes, if not, how are you? I mean, what is the biggest bottleneck for you guys for the respective solutions that you are building?
So data availability, as it stands today, certainly it is a potential bottleneck. There are EIPs or Ethereum improvement proposals put forward that we are very excited about that would dramatically reduce the amount of data that would need to be permanently stored on Ethereum layer 1. So that's going to help. But what's more exciting is when we get to a sharded based layer where the data no longer is replicated across the entire network, but only a subset. And that represents a much more scalable data availability layer. And then on top of that, there are other techniques that could then further improve scalability, such as erasure encoding and various other techniques that have been honed over the years in the storage cloud world. And I happen to have come from that world, actually. I built a company and I was head of product of a storage cloud startup previously. And so I'm pretty optimistic about the future of data availability, no pun intended, that it's not a huge concern to us.
Yeah. So I would agree with Alan about this, mostly that data availability is a bottleneck today, but that is a temporary state of affairs. And that's true for a couple of reasons. One is Ethereum's roadmap, right? The rollup-centric roadmap for Ethereum, one of the things that means is that Ethereum is moving in the direction of providing much greater data availability and making that a focus, right? The rollup-centric roadmap says Ethereum provides large-scale data availability and a settlement layer. And the data availability part of that means that data availability doesn't need to be a bottleneck. And I think it won't be. Fundamentally, data availability does not need to be a bottleneck, just from sort of computer science first principles. There's also discussion about other approaches, whether it's something like Celestia or some of the other schemes, whether it be Validium or our AnyTrust or other schemes like that, where you move data availability into a different layer or system, which is trustworthy enough to provide you with, so that if you're willing to make a minor additional trust assumption, that you can move to something else sooner than Ethereum is going to do it. Over time, I think Ethereum is going to provide the data availability capacity that's needed as it continues to evolve, and that's on Ethereum's roadmap. So I'm less worried about it in the long run. When we think farther out, Right now, we're focused a lot on optimizing the data footprint, but as we focus farther out, we'll obviously continue to do that, but it will be more focused on other limitations and how we can bust through other barriers.
Yeah, I mean, we have been also like, I mean, keeping a strong eye on the data availability, that when our solutions come out and that there is adoption coming, the data availability both in the short term and the long term should not be any issue. So that's why like we have a product called Polygon Avail, which I think is the only solution except Celestia, which is building a general purpose data availability layer. And we are actually building it keeping the Ethereum rollups in mind only, and it's doing well. So but we I agree with Ed that Ethereum's roadmap also with, I think, 4844, it is EIP 4844, which intends to provide larger and easy and low cost data availability on top of Ethereum. I think that could be a very significant solution. And let's say in 3 to 5 years, if Ethereum moves fully into, if at all, I'm saying, into the sharded, fully sharded architecture at 64 shards, I think data availability will be solved. But on a larger scale, the kind of demand that we are seeing, I mean, this whole like last bull cycle, and I'm saying last because I think we are definitely in a bear market. So the new bull cycle will bring in even more thousands of developers into the space, and the need for that data will be very, very high. So even though Ethereum is providing that, we are also building a general purpose solution which anybody can use, which for the data availability also, because then it will be the only bottleneck in the short run and short to medium run, and that's what we are trying to solve with the Polygon Avail solution.
And your thoughts, Ellie?
I don't have much to add. Data availability is a big problem. Yeah, I don't have anything smart to say at this point. We're very aware of it. We're doing research on how to do things a little bit better or different. But yeah, I don't want to waste the listeners' time because I don't have anything deep to say on that.
Okay. I think we have like 8 minutes left. I should pick up the important questions before we can dive deeper into these matters, right? So, outside of securing roll-up networks, how do you see the role of tokens, and what are the other parameters that you consider uh, whether you want to launch a token and when you would want to launch it? I know that Boba Network and Matic, which is Polygon, they already have their tokens. So maybe you guys can speak about what role the token plays in the current ecosystem, and Ed and Ellie can talk about whether they want and when.
Sure, happy to start. We started off the network with a token. So first of all, the token, the Boba token is used to pay for gas. In addition to ETH, you can choose either one of them to pay for gas on the network. Anytime you make an off-chain API call, you also pay for that in Boba. And no, the amount is nominal, but the intent is to prevent spamming. It's also acts as a governance token for the Boba DAO, which votes on governance proposals for the network. We started a network with a token right off the bat because we realize how important it is to have an engaged and active community around any blockchain projects. And ultimately, we are not building the network for ourselves, we're building it for the community. And having a native token really helps to galvanize the community. They pay attention to it. They will champion for it because they feel like they own a piece of the action.
Yeah, so I mean, for Polygon also, we believe in that multi-chain future, and I think that the token for all the public chains, which we'd want to ensure censorship resistance, they would have that Matic token as the staking token for the data availability chain, as well as, like, for example, our Polygon POS chain. The token is basically to ensure that there are more than one validators in that chain, and basically to decentralize and have more censorship resistance on this, even when they go into the roll-up setting. But they will also be I believe that there will also be like single operator roll-ups also, which might not need a token, but they would also have direct connectivity into these larger hubs, like, for example, Polygon POS has kind of become a hub last week. Like, Uniswap had like a 1.4 billion volume in the last week on Polygon PS chain itself. So we believe that some of these, out of these multi-chain future that we see, some of these chains will have will behave as a kind of hub. So there also the value will trickle down into this. And also, as Alan was saying, that Matic token will also be be the governance token of this of Polygon DAO, which will basically which one thing that I'm also very excited about is that for these layer twos, they will kind of have both kind of governance, on-chain and off-chain governance. Like off-chain governance is basically their validators exerting their control on the node clients. But basically the connecting smart contracts on Ethereum would also have some level of control or decision making power, which Polygon tokens community will make on how these parameters should be on some of these chains. So definitely it will be a governance token also. And then for the Polygon Avail chain, it's a pure data, proof of stake data availability chain. That should also be that will also be one of the use of the token. Gas fees we are not sure about. Like we in fact feel that the Polygon POS chain should not have had Matic token as the gas fees. It adds a additional user experience issue. It should have been simply ETH itself or USDT, because the users can also then actually see what is the actual GUI fees they have to pay on the layer 2 and layer 1. With this, right now they are using Matic token, so it's not optimal. We are right now thinking and are settled on basically all the new chains having default ETH as a gas fees, and the token value accrual is purely on the staking layer, is what we believe.
Ed, you want to go?
Do I want to go? Well, so let me say this. I think everyone in this space either has a token or has thought about a token, so we decided from the beginning that we were not going to, or that we were going to have ETH be the native currency on our chain, and we did that to reduce friction and as part of a general compatibility strategy, in order to be compatible with wallets and so on. ETH has been and will be the native token on our system. As far as anything else beyond that goes, there's obviously we've thought about it. We haven't announced anything, I think we launching a token is a door that only goes in one direction. When you do it, if you do it, you then can't go back, and so it's something, obviously a possibility that we're aware of and are thinking about.
That's very nicely said. It's a one-way door, and to hell also. Like as founders, it's a lot of responsibility having a public token, and especially when you launch at a very early stage of your startup. It's like it makes your startup journey, I think, 5x harder than like a normal startup journey.
I have to agree with Sandeep on that one. It's like running a publicly traded company.
Yeah.
Eli, your thoughts?
Some thoughts. So I mean, I was part of one token launch, Zcash. I saw it in a tweet and it just stuck with me because it resonates as so true. So it's a tweet by Andre Cronje, who said, launching a token is like ripping your heart out and putting it on a missile. Very aware of that. Must be true. Another thing I want to say is that these past few months I've been going down the rabbit hole of like reading a lot about macroeconomics and the history of money and things like that. It's a fascinating story. I think one of the first realizations, by the way, Larry asked about the birds. So it's migration season. I'm up north in the Jordan Valley, a lot of birds, but these are actually, I'm in some resorts, so the cries, you may recognize them. There are peacocks around.
Yeah. I could recognize that coming from India. Like it's a peacock.
Yeah. And the peacocks are not migrating. There they go again. Okay, anyways. So one realization is that, first of all, money, which is form of token, certainly today, is a human invention, and it's very much by trial and error. So human society has been stumbling along and trying things, and of course there were some catastrophic failures. And actually, in the past decade or two, there are like some very bold, attempts. I'm talking about, quantitative easing and things like that, and MMT, and this is completely uncharted territory. Now, that's like in the big game of like all of the world. In our smaller corner of crypto, there are these amazing experiments going on. Each one of them is a fascinating experiment in human behavior and consensus. Of course, it all starts with Bitcoin. And tokens are a very good way to reach decisions, especially now I'm talking about on layer 2. So they're very good for governance. They're very good for cohesing a community. They're very good for aligning interests and making sure that there is ongoing development, and as ways to make an ecosystem thrive and successful. And all of these lessons are not lost on us. Our reaction to when token has been for a very long time no comment, and I'll stick to that.
Yeah, I think. Yeah, I mean, I guess we just have to see what happens, right? So, thanks a lot for that answer. I think I'll be cognizant of all of your time. I have a lots of pending questions, and I think even the audience has posted a lot of questions. But unfortunately, I think we have run out of time. So, if people want to reach,
Instead of asking whether there will be a token or not, you should ask how to get the airdrop whenever there's token. Maybe you can trick them into telling.
No comment.
That's a double.
Yes.
Look, I think Sandeep, everyone here is way smarter than me, and I don't think I can trick them into anything, right? So,
Yeah.
all right. So, how can people reach you? And if they have questions or they want to follow you, how do they do that? Just let us know that.
Okay, we
Yeah.
posted in the chat just some some things to. I'll just post mine in the chat.
Okay. Cool.
Yeah, find me on Twitter. Alan Chu is my handle.
All right. Thanks a lot, gentlemen. I think this was a lot of fun for me. I could go on for another hour because I haven't scratched like I've barely scratched through my list of questions, and I wish we could go on. But yeah, thanks a lot again for spending time with us. Thanks everyone for joining us from
Thanks,
I think
Saurabh.
across the world. Yep.
Thanks.
Thanks for having us.
You're right.
Guys, perfect time. Bye, guys.
Bye.